Okay, this is lesson 2.3 about postulates, proofs, and properties, and how to write a proof. So first we're going to go through and review a lot of the properties and definitions and rules that we've learned in the past. And these are all things we can use when we're writing a proof, which is what we're going to start doing today. So we'll start with the properties of equality that you learned in algebra. The reflexive property. This one seems kind of strange, but it's one of the most common ones we use in geometry. The reflexive property just means that everything is equal to itself. So anytime you see the exact same thing on the opposite side of the equal sign, or the congruent symbol, so occasionally you'll see something like segment PQ is congruent to segment PQ, that's reflexive property. The measure of angle 1 equals the measure of angle 1, the exact same thing on both sides. The symmetric property. The symmetric property means that things are allowed to swap places across the equal sign. If AB equals CD, then CD equals AB. So if they just swapped places across the equal sign, that's the symmetric property. The transitive property. If GH equals JK and JK equals LM, then GH equals LM. I think of the transitive property kind of like a little train. We've got GH and JK, and then noticed we used JK again with LM. That means that GH and LM are equal, the transitive property. Sometimes this also looks a little bit like substitution. So there are a lot of times where we will accept transitive or substitution. But transitive, it's like a little train. It's connecting three statements together. If so over here, if angle 1 equals angle 2 and angle 2 equals angle 3, then we know that angle 1 and angle 3 were equal. The addition and subtraction properties, those are properties we use when solving equations. So for example, the addition property says I can add the same number to both sides of an equation and it's still equal. The subtraction property is the same way. I can subtract a number from both sides of the equation and it's still equal to each other. The same thing with angles. Multiplication and division. The same rule. I can multiply both sides of an equation and it's still equal. Or I can divide both sides by the same number and it's still equal. Substitution. If two things are equal, I can substitute one in place of the other. And you'll see that a lot where we take two things that were equal. Definitions. Here are some definitions that we need to know, and the wording of them is very specific. So the definition of a perpendicular line. Perpendicular lines intersect to form a right angle. That's the definition. Notice it doesn't say intersect to form 90-degree angles. That's another step. So perpendicular lines, right angles. Supplementary angles, like we've learned, two angles that add up to 180. So supplementary angles, angle plus angle equals 180. Complementary angles, the same thing, except complementary angles add up to 90. Now we have the definition of a bisector. A bisector cuts an angle or segment into two equal parts. So for example, if I tell you that this ray is a bisector of the angle, so if I said ray BD bisects angle ABC, well, what do we know? I know a bisector cuts this into two equal parts, so now I know that angle 1 is congruent to angle 2 because a bisector makes two equal parts. And here's the definition of a right angle. A right angle equals 90 degrees. So perpendicular lines form right angles, and then we know that right angles are 90 degrees. A couple of postulates and theorems. A postulate is just a rule that we accept to be true. So it's kind of like a property. It's just a rule that, well, we know that's true. A theorem, somebody had to prove it was true. And fortunately for us, someone else already did most of them for us. So we don't have to prove a lot of the theorems. They just kind of tell us this is a theorem, and we're like, good. The linear pair postulate that you learned, linear pairs are supplementary. And then we know what the definition of supplementary means. They add up to 180. So You are welcome to call it the linear pair postulate in your proof, or if you can't remember the name, just tell us what it says. Linear pairs are supplementary if you can't remember the title. The vertical angle theorem says that vertical angles are congruent. Again, if you can't remember the title of the theorem, just tell us what it says, because that proves that you understood. Now I want you to notice the vertical angle theorem says that vertical angles are congruent. It is not the definition of vertical angles. The definition of vertical angles just tells us what they are. It doesn't tell us that they're congruent. So don't ever, ever, ever use the definition of vertical angles, because that's not a thing. All right angles are congruent. That makes sense, because every right angle is 90 degrees, and go back to the reflexive property, 90 equals 90, so all right angles are congruent. You can use that in a proof. Segment addition. Remember we had the little segment plus the little segment equals the big segment. If you remember segment addition, we use that one a lot in our, especially starting out. AB plus BC equals AC. Then we had angle addition. Here's an example up here. If D is inside, then ABD plus DBC equals angle ABC. The little angle plus the little angle equals the big angle. All right, so those are all rules that you have at your disposal when we start to write proofs later. So next up, number 1 says, we're going to do always, sometimes, never. Fill in the blank with one of these. 2 planes intersect at a point. Remember, a plane is a flat surface. Can 2 planes intersect at a point? I'm going to go with never, because 2 planes actually intersect at a line. They can't intersect at a point. Any 3 points, always, sometimes, never, creates a plane. That wasn't always. Remember, if we gave you 3 points, you would say they are always coplanar. A line exists through any 2 points. That's another always. 2 points always make a line. A line will blank intersect with a plane. Does a line always intersect? Sometimes or never? I'm going to say sometimes, because if the plane and the line are parallel, they're never going to intersect. Other than that, the line will intersect. 3 points are coplanar. We had this one on the last test. 3 points, always coplanar. 2 points, always collinear. Okay, so those are all some of the postulates that existed when we were learning our rules earlier. All right, let's move to the next page. Here's an example of a proof. And this is something we're going to learn how to write. One of the purposes of proofs is just to get us thinking. You have to kind of think like a lawyer. You are presenting evidence that helps us start with the given and end up with the proof, and everywhere in between you justify your statement. Well, this statement is true because of this evidence, or this evidence is true because of. This is true because of. So you're like a lawyer in court, and it's very detailed, and it's going to seem tedious, but it's just a way of developing our logical thinking skills. So we start here. They told us that angle 1 was congruent to angle 3 in this picture. And then they want us to prove that angle ABE, this one right here, is congruent to angle CBD, this one right here. So that's our job for this proof. Let's see how they do it. Well, the first thing they said was that angle CBD is angle 1 plus angle 2. So if you can see the one I did in red, angle CBD is angle 1 plus angle 2. Well, that's just the little angle plus the little angle equals the big angle. Angle addition. We did the same thing with ABE. Angle 2 plus angle 3 equals angle ABE. Angle addition. Now look what happened in number 3. I always like to look at a statement and look above it and see what changed. Well, right here we said that angle ABE was equal to angle 3 plus angle 2. What changed? Now we're saying that angle ABE is angle 1 plus angle 2. Well, how did angle 3 become angle 1 all of a sudden? Looky here. Aren't angle 1 and angle 3 equal? Because that's what we were given. So if two things are equal, I can take one out and put something else in its place. That is substitution. Now look at number 4. I can now say that ABE and CBD are equal because look at angle CBD. It's 1 plus 2. And now look at angle ABE. It's now angle 1 plus angle 2. If they equal the same thing, well, they have to equal each other. I would take substitution or transitive property on this one. We started with the given. We ended up proving what we were asked to prove. Notice the word prove does not appear in your proof. The word given does. Given, we just list what they gave us at the beginning. We said this is our starting point, and we're going to work our way towards here. But don't ever write the word prove because that's always wrong. Pick another word. Try a definition or a property, but don't use the word prove. So to get us warmed up with our proofs today, we're going to start with some algebra proofs. So here goes. You've solved algebra equations for a while, and we're going to walk through step by step justifying, and that kind of gets us warmed up for the geometry proofs. So number 1, we're going to start with the given. And we're going to write the word given. This is what you gave me. This is where I'm starting. All right, so in my next step, maybe I'm going to write 15 equals 3p minus 3. So you're looking at it thinking, what did I just do to both sides? Well, what changed? Well, the 7 became a 3, and the 4 is gone. So what did I do? I subtracted 4 from both sides. That's the subtraction property. I'm going to call it subtraction, and then POE stands for property of equality. You could probably just call it the subtraction property and be just fine. I subtracted the same number from both sides, so that's the subtraction property. So in my next step, maybe I write 18 equals 3p. I say, okay, what did I do to both sides? Well, the negative 3 is gone, so I bet I added 3 to both sides. So that would be the addition property. Again, if you just want to call it addition property, I'm okay with that. And last but not least, what do we do to both sides? We get 6 is equal to p. That's the division property because I divided both sides by 3. And if you really wanted to be fancy, we could add another one and say that p equals 6. Do you remember the property that says we can swap places across the equal sign? That was the symmetric property. The symmetric property. So that's just an example of a quick algebra proof to get our brains warmed up to think about what proofs look like. Let's do number 2. Number 2 says 4/5 x plus 8 equals 20. So we're going to start with step 1. Write the given. You don't have to put the given in step 1, but it's just a great place to put it. And that's one part of the proof you will always get right because you just write the given. Okay, so I'm going to say 4/5 x equals 12. And then you're going to think about, what did I do to both sides? I subtracted 8. So we're going to call that the subtraction property. I just abbreviated it with a symbol. Now this one, let's see, I think I'm going to get 15. So now I'm going to ask you, what did I do to both sides? Well, the 4/5 is gone. So what did I do? Did I divide by 4/5? Or maybe I multiplied by 5/4. I'll do that up here. So on this one, depending on where your brain went with that, if you divided by 4/5 or if you multiplied by 5/4, I'm going to say division property. I'm sorry, I'm going to say multiplication property because I multiplied by 5/4. If you divided by 4/5, you would have said the division property. Or maybe you did it in pieces. Maybe you multiplied by 5 and then divided by 4. We end up with the same answer. So that works. All right, let's do number 3. Then we can look at some geometry proofs. 5d plus 17 equals 4 parentheses d plus 3. That's my given. All right, I'm going to do step 2, and you're going to tell me what I did. You probably remember this one. I did the distributive property. We didn't list that on the other page, did we? The distributive property, that's my favorite property. It's weird I have a favorite property, but I do. Now we just solve it kind of like we did the first one. I'm going to say d plus 17 equals 12. What did I do to both sides? I subtracted 4d. Subtraction property. And now I'm going to say d equals -5 because I subtracted 17 from both sides. So again, another subtraction property. So you can use the same property more than once in a proof. As long as that's the correct justification for your statement, you are A-OK. So there are some good examples of some algebra proofs, and I think I'll post another video with some beginning of the geometry proofs for you. So here's a geometry proof. It's number 10 on the back of the homework. So I thought I'll just work this one out with you, and maybe that'll get you started. This one says we're starting with the fact that ray BD bisects angle ABE. So here's ray BD, and it bisects angle ABE. Now I realize that might not look perfectly like a bisector, but we're not judging by what it looks like, we're judging by what we're told. We're told it's a bisector, so it's a bisector. So your brain needs to automatically go to, what's a bisector do? I know that definition. So I'm going to start my proof with given ray BD bisects angle ABE. And for my reason, you gave it to me, so I write down given. Now let's look at what we're going to try to prove. We're going to try to prove that angle 1 plus angle 3 is equal to angle DBC. So I hope you see angle DBC here, right here. So we've got to make it say angle 1 plus angle 3 is equal to DBC. Well, I'm looking at it thinking that angle 2 plus angle 3 equals angle DBC. So I think I'm going to say that in my proof. Sometimes if you don't know where you're headed, or you know where you're headed but you don't know what to do, you just write something that you know is true. So I know that the measure of angle 2 plus the measure of angle 3 equals the measure of angle DBC. And I know that because the little angle plus the little angle equals the big angle. That's called angle addition. So angle addition. Now, let's think about, we haven't dealt with the word bisect yet. Remember what a bisector does? It cuts something into 2 equal parts. So if angle ABE just got cut into 2 equal parts, what are they? What are the 2 equal parts? Angle 1 and angle 2. So I can say measure of angle 1 equals the measure of angle 2, because that's what a bisector does. The definition of a bisector. So it's really important to know those definition and properties. Now, I think I've got something. If angle 1 and 2 are equal, can I take angle 2 out of here and put angle 1 in its place? And that'll get me what I'm trying to prove. So I can replace angle 2 with angle 1 because they were equal. And now it says angle 1 plus angle 3 is equal to angle DBC. So remember, if two things are equal, I can replace one with the other. That's called substitution. And I think that's what we were trying to prove, that angle 1 plus angle 3 is equal to angle DBC. We're done. So we started with the word bisects, so I used that definition, and then I used angle addition and substitution. So that's a good example of one of our geometry proofs. So I think I will also do number 9 because I really want you to get the definitions that go with this one because it's really important to me. So we're starting with the fact that line AB is perpendicular. Remember, the upside down T means perpendicular to line DE. So AB is perpendicular to DE. So let's start with that as our given. So you never miss the first statement. Just put all the given in the first statement and you've got that one right. Now I'm going to go back to my definitions and look at the definition of perpendicular. What do perpendicular lines do? They form a right angle. So look back at your picture. What are the right angles? Well, there's one here, 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 and here. But I don't think I need to list all of them. Maybe I just need to list angle ABD and angle CBD because those are the ones I'm writing a proof about. So I'm going to list those as my right angles from the definition. So I'm going to say angle ABD and angle CBD are right angles. And remember why they're right angles? It's right here. The definition of perpendicular lines makes right angles. So number 2, definition of perpendicular. You're welcome to use that symbol if you don't want to write that word. Now, what do I know about right angles? Well, back to my definitions. What's a right angle? An angle whose measure is 90. So can I say that both of my angles equal 90 degrees? According to this definition, I can. So I'm going to say that the measure of angle ABD equals 90, and the measure of angle CBD equals 90. And my reason? Well, we just looked at it. The definition of a right angle. We're almost there. Because, remember, if two things equal the same thing, they have to equal each other. So because both of these equal 90 degrees, I'm going to go on and say that angle ABD is congruent to angle CBD because they were equal to the same thing. You could write transitive property, or I would even let you write substitution. If two things are equal to the same value, they're equal to each other. And there's our proof. So I wanted to start out with helping you with how to go from the definition of perpendicular to saying that they're right angles, and then you can say they're 90 degrees. So good luck on the rest of your proofs, and happy thinking.